Welcome, this is question 8 for Edexcel's C4 June 2008 past paper. Okay, so this is the last question. I'm going to try and, not go too slow. Anyway. Okay, so we're given that there's this curve, so what the equation of this curve is, we're given obviously it's the x is 8 cos t and the y is 4 sin 2t. So it's a parametric curve, okay? And we've got this line which cuts through C at point P, which we are told has an x coordinate of 4 and a y coordinate of 2√3, okay? And we're asked to find, for part A, to find the t value of this point, okay? So we know x is equal to 4 and y is equal to 2√3. So essentially what we need to do, because obviously we're dealing with trig functions here, it's obviously when we try and find it in a certain range, and the range we're given is between 0 and pi on 2 for t, we're going to get different values for t for each of them. However, in theory, we should get one value for t that satisfies both equations, okay? So that's what we're going to do. Now the first one I'm going to start off with is x, okay? So we know that the x point of P has x as a coordinate 4. So we just put 4 is equal to cos t, okay? Sorry, 4 is equal to 8 cos t, so therefore cos t is equal to a half, or 0.5, cos inverse both sides, so therefore t is equal to the cos inverse of a half, so therefore we get a value for t to be equal to pi on 3, okay? But that is the value for t. Yeah, correct. But as I said, we could go on to find another value, but there's no other values for cos t that lie inside the range 0 to 2 pi that would give us an answer of a half as required, okay? But what we need to do is prove or make sure, kind of hope that our working is right, and when we put that 2√3 is equal to 4 sin 2t, we should get a value for t to be pi on 3, okay, hopefully, but we're just going to assume as though we didn't know that, okay? So what we need to do is put 2√3 is equal to 4 sin 2t. Obviously the first step is to divide both sides by 4, so that just gets you root 3 on 2 is equal to sine of 2t, and obviously 2t, we're going to need to modify our range a little bit, okay? So anyway, sine inverse both sides is normal, so therefore you get 2t being equal. If you sub that in your calculator, you should get the sine inverse of 2t. The sine inverse of root 3 on 2, 3 on 2 gets you pi on 3. And now you go, that's the same. But remember, this is 2t, not t. So obviously that's not the value that we want, okay? So what we have to do is, what I do is draw the cast diagram, okay? And hopefully you understand what I mean by the cast diagram. Cos, all, sine and tan, that's where they're positive, okay? And this is 0 and 2 pi, this is pi, and this is either negative pi on 2 or plus 3 pi on 2. Okay, as I said, as I do explanation for the cast diagram in the C2. So I'm assuming whichever way you want to find the other solution, okay, it doesn't matter which way. So we know that the sine is positive, so sine is positive in the all and sine, okay, so it's pi on 3, okay, so what you do is you do pi, take pi on 3, which should get you 2 pi on 3, okay, and then when we divide both of these, because that's the range now, we've got up to the maximum range of pi, okay, so what we do is we divide both sides by 2, so it's pi on 6 and pi on 3, okay, so as t is pi on 3 here and pi on 3 in the x, when we find it through finding x, therefore we say the t coordinate of P is pi on 3. Okay, and that is that's the explanation you need to do. You can't just assume because you got it in x, that's the value, okay? You need to prove that you get it in the y way of thinking about it as well, to prove that it's actually there, okay? So sort of like double backing yourself. Alright, so hopefully you've got that. I'm just going to put that out now. Alright, so what we're going to go on to now is we're going to move on to part B. I do apologise. Part B says line L is a normal to C at point P. Show that the equation for L is y is equal to x minus x root 3 plus 6 root 3. Okay, well, the bit of information it's told us is it's normal. So we need to work out, obviously, the gradient at P and do the negative reciprocal of it. Okay, so the first thing we need to do is work out the gradient at P. So it's just a case of using dy dx, but because the equation, the curve that P is on is a parametric curve, we need to use that kind of latest rates of change theory. Okay, so dy dx is equal to dy d something, and the only thing we can differentiate y with respect to is t. So it's dy dt, and it's the same d something, so dt over dx. So in essence, it's the differential of y, so it's the differential of y, so y dashed over x dashed, because we did times the differential of y by 1 over x, so it's the differential of y over the differential of x. Okay, so I'm going to sort of skip out that step, so hopefully you understand why this is. Alright, so differential of y, well, 4 sine 2t. Well, when you differentiate sine, the sine stays the same, okay? But obviously the actual trait changes. And because it's sine 2t, not just sine t, we have to times it all by 2 as well, so it becomes 8 cos 2t on the top. Okay, and then when we differentiate 8 cos t, well, the cos changes sign, because 8 cos can do, I tried to be smooth there, it didn't work. Okay, so that just becomes negative 8 cos t. Now we can't, sorry, negative 8 sin t, I do apologise. Now we can't, my temptation at this point was to go, we can make that into tan, because it's, cot, sorry, because it's cos over sine. But this is a double angle, this is a single angle, and therefore you can't. Okay, now you could cancel the 8s if you wanted to, it doesn't really matter. Okay, what we need to do now, we know the t value at P is pi on 3, so we just sub pi on 3 into this equation, okay, to find the gradient. So 8 cos 2 pi on 3 over negative 8 sine pi on 3. Okay, remember this is the gradient of the curve at this point. We want the gradient of the normal, so we're gonna have to work whatever this is out, which comes to be 1 over root 3. Okay, so therefore the gradient of the normal is a reciprocal of this, so m of the normal is equal to negative root 3 over 1 or negative root 3. Okay, so that's the gradient of the normal, but it wants the equation of the normal to P, okay, which is this line L. Alright, so we know the point P has an x coordinate, sorry, I shouldn't have rubbed it out. P has the x coordinate at 4 and y coordinate 2 root 3. Okay, so that's at P. So our x value is 4, our y value is 2 root 3, our gradient is negative root 3. So it's just a case now of putting this into a standard y take y1 is equal to m brackets x take x1, okay, and expanding it as required. Okay, so y take y1, so y take y1 being 2 root 3, okay, is equal to negative root 3 brackets x take x1, which is 4. Sorry, I do apologise. And then you just, a case now of expanding this, so y take 2 root 3 is equal to negative x root 3 plus 4 root 3. And then you add 2 root 3 to both sides, so therefore you get y is equal to negative x root 3 plus 6 root 3 as required. Okay, so I mean, I would always put as required to the examiner. You don't get the snotty-nosed examiner, not that you would, that says, even though you got the right answer, I'm going to deduct your mark, and then you have to pay £20 to get your exam back, which they mark it up, that the examiner should have done in the first place. So really, you just wasted 20 quid. But anyway, think of much. I haven't wasted 20 quid on a night. Okay, so that's the equation of the curve. Okay, sorry, the normal. I apologise. So this line L has the equation y is equal to negative x root 3 plus 6 root 3. Okay, so that's part B. Part C, it's asking us to work out this area R, or the area in red that I've sort of removed the R from. Okay, and we've got to integrate it to the line x equals 4 and the x-axis. Okay, sorry, not this part here. So just up to P. So sort of that part of the curve there, and we've got to show it is equal to the integral of limits pi on 2 and pi on 3, 64 sine squared t cos t with respect to t. So we've only got to show it for part C, and then we've actually got to work it out for part D. Okay. So what I'm going to do is I'm just going to rub. Sorry, my camera's going to have to focus again. No, isn't. Okay, so what I'm going to do is I'm going to rub this bit of information out, and then we're going to recap what the gradient, sorry, not the gradient, what the integration for parametric functions actually is. So the integral that we have for parametric functions is the integral of fx dx is equal to the integral, we use integration by substitution, integral fx times dx, and instead of I'm going to write dt, and we're going to let y is equal to f of x, okay? So we just put y where f of x is, okay? So hopefully that makes sense. Now what we're going to do is just simply work out what dx by dt is, and keep it. Oh, one sec, I'm just going to need to do something. So as we were saying, before my camera decided to pack it all up and sort of run out of battery, okay? Because it's talking too long. Anyway, so we said the integral of a function which we called y with respect to x equal to y times dx by dt, or with respect to t. Okay, so the first thing we need to do is find dx dt. And now this is a lot easier than when we were simply just integrating a term, because when we differentiate, basically this is saying differentiate the x equation with respect to t, and the only thing we can differentiate the x equation with is respect to t. So it's just simply differentiating that and timing it by y. It's that simple, okay? So dx dt, okay? So if you work that out, well, it's obviously just going to become negative 8 sine t, okay? And then all we do is times that by 4 sine 2t. However, as I said, you can write this, or you can not. As I said, you know, if you feel like you want to skip a step. Now, just preliminary, I'm going to write the limits as 4 and 0, okay? Now, they're x limits, okay? And obviously, we're integrating with t, so we're going to need to change them at some point. But I'm just assuming that you can understand that, okay? So you times that by 8 sine t. Now, we can't make this 32 sine 2t sine t, because these are not the same, and you can't times a by b. You can't have 2ab kind of thing, okay? That makes sense. Basically, they need to be the same angle to be able to apply that method. So therefore, we need to use a double angle formula for sine. And you should know that sine 2t, okay, is equal to 2 sine t cos t. Okay, so therefore what we do is sub this into that equation and rewrite it, okay? And obviously all this is with respect to t. I'll get to the limits in a minute, so don't worry too much, okay? Anyway, okay, so 4 times sine 2t cos 2t, so 4 brackets, 2 sine t cos t. And we times that by 8 sine t. Okay? Or with respect to t. Okay? So when we simplify this down, so obviously we're going to be left with therefore 8 sine t cos t. And then we times that all by 8. Okay? Therefore, because this is sine t times sine t, what we've got is we've got the integral of with limits 4 and 0, so now the final limits, of 64 sine squared t cos t with respect to t. But it's a show that question, and it says in the show that question, well, it proves that the limits are not 4 and 0. In fact, the limits are pi on 2 and pi by 3. Okay, now these are the x limits, so this is what x equals. So you can put the top limit is x equals 4 and the bottom limit is x equals 0. Okay, so the only thing we can do with this is, well, we need to change them to t limits, okay, because we're not being asked to work this out just yet in part C. All I have to do is make it equal to the integral with limits pi on 3 and pi by 2, which doesn't quite make sense because the top limit is normally bigger and in this case it isn't. Don't get worried about that, okay? Anyway, right, so shut up. So, well, I won't shut up because I need to talk. Okay, so the top limit is x equals 4. So, from our x equation for the parametric functions, we're just going to make it equal 4. So, x equals 4 equals 8 cos t, okay? So you rearrange to get t, so it's the cos inverse of 8 over 4, or the cos inverse of a half, okay? And if you do the cos inverse of a half, you get pi on 3. So we can replace the top limit, you could write this out again, but I can't be bothered. The top limit as pi on 3. The bottom limit, now we're still focusing on the x equation because it's x equals 0. So 0 equals cos t, so therefore t is equal to the cos inverse of 0, which if you work that out, you get a half. Now, I do admit that you go, okay, well, when we normally do cos inverse something, you normally get us to draw the class diagram. Well, no, I don't force you to, obviously. I wish I could, though. Anyway, apart from the weirdness, that's because our limits are between 0 and pi by 2. So, if you can draw the class diagram, but that we'll only get one value because, well, if you think about the segments, we can only go past one segment, if that makes sense. If it doesn't, just, you can try and work it out yourself, but you'll get a value that is greater than, for t, that is greater than pi on 2, okay? So, that's why we can't, that's why it's pretty pointless to be doing that class diagram, because it'll be a bit of a waste of time, really, okay? Right, so that's part C out of the way. And part D asks us to find the area R, giving the answer in the form A plus B root 3. So basically, in essence, we've got to integrate this and solve it. Now that's very difficult. My first thought, when I first saw this question, I thought, well, what we've got a sine squared t and a cos t, and the only other time we have that is think, okay, what do we differentiate to get that? Okay, and well, what we differentiated was, you could think about what would differentiate to get that. Now, obviously, it would be some kind of sine cubed, okay, but then we've only got cos on its own, and naturally we would have, cos squared t or whatever it might be. Okay, so really going down that road of trying to guess what we differentiated to get that answer, so we can integrate it to get the answer that we differentiated to get it, because the differential, if we differentiate something, it's the opposite of integrating something. I kind of showed you that little idea before. Anyway, okay, so as I said, going down that method would be quite difficult. So what I'm going to do is I'm just going to kind of rewrite this over here, because obviously this is going to take quite a bit of working out. Okay, now hopefully, I'll leave the diagram on. I was going to rub it off, but I can't be bothered. Okay, there's a lot of can't be bothered stuff on today, I tell you. Anyway, we said the limits were pi on 3 and pi on 2. All I'm doing is rewriting it out now. We said that was 64 sine squared t cos t. Now this isn't specifically, this is a really nasty question actually, because on the mark scheme and obviously on my answers as well, I use the substitution, integration by substitution, because, well, you could use, say, integration by parts, but we've never used, well, I rarely have ever used integration by parts. I mean, correct, granted we've got a function, sine squared t, times cos t. Now, we could take 64 out of that idea, because it's sort of like you timed the answer by 64 anyway, so there's no point having it in the integral, okay? So you could use integration by parts, but personally I wouldn't do that. I might do another video later on, depending on what kind of time I've got, to do the alternative method to answering this question. But for this question, what I'm going to do is just rewrite this almost in a slightly different manner, okay? So keep the limits pi and 3, pi and 2, okay? 64 times, now sine squared t is the same as sine t times sine t, or sine all squared t. So I'm just going to write it in brackets of sine t all squared, okay? I've not changed the equation, I'm just writing it in a different way. And when we started looking at integration by substitution, to try and simplify it down for me, and you if you needed it to, obviously, tried to do it a bit smoother, but I don't know if it worked. Anyway, what I did was I said, okay, well, always the substitution is always a thing inside the brackets. Well, in this case, we didn't have any brackets, so there's nothing you could have done with that, jumped out straight away. And as it hasn't told us to use integration by substitution, realistically, you can pick any substitution you want to. But I think this method, we're splitting it up, because now what we've got here is the sine t is in the brackets, okay? So I'm going to use a substitution, u is equal to sine t, okay? Because it's inside the brackets essentially. We've just put it in some brackets, and because it's sine squared t, it's sine t all squared, okay? So as I said, that's the way that I thought about it, or you could easily use cos t as the substitution, but I think it'd be a bit of a risky manoeuvre, because the integration by substitution equation is kind of similar to the one we just did to get this, okay? Where we said the integral of f of x, a function, is equal to that function times dx by du, okay? So that's 1 over du dx, okay? With respect to u. And if you try to differentiate, cos t, actually no, using the substitution of cos t is quite simple. But, you know, it's up to you which way you do it. It's not really bothered. Probably should have done it that way. I will do another video, the alternative method, but as I said, I quite like this one. Okay, so what we're going to do is times all of this, okay? Now you can rewrite it back as that. I was just splitting this up to show you where we're going with this, okay? So that we're going to times all of that, okay? So that's the function, and we're going to times it by dx by du, or 1 over du dx, okay? And dx du, I do apologise, because we haven't got any x equations. Sorry, just God. Sorry, we're going to times that by dt du. I do apologise. Yeah. Not du, dx du is dt du. Sorry, do apologise. We're looking at thinking that can't be right. Okay, so just refer to my answers before I start going completely crazy. Yeah. Okay, so therefore du dt, because that's all we can do so far. We've got the u equation, we can only differentiate it with respect to t. We get cos t, okay? So du dt is equal to cos t. But what we actually want is dt du. So it's dt du is 1 over cos t. And 1 over cos t is also known as sec t. Okay, but you can leave it as either. But in my answers, I've changed it. I've left it as 1 over cos t, okay? And there's a reason for that. Okay, so we times it by 1 over cos t. And when we times something by 1 over cos t, it's the same as obviously divided it by cos t. Alright? So, what essentially we do here is, let's just rewrite this out with in a simpler form, okay? So I'm not going to do any integration just yet. Pi on 3, pi on 2. Okay, and what I'm going to do is I'm going to bring the 64, let me just check if those are the answers. Oh, yeah, I'm going to bring the 64 out in front of the integral, okay? So I'm not bothering trying to integrate the 64. Not because I just want to do that, but because I you know, lazy. Okay, so anyway, sine squared t, cos t, all over cos t. Now we should notice straight away that these cos t's cancel. Okay, so we can rewrite this out again, just in the form of it being with respect to sine squared t. So pi on 3 limits, pi on 2, okay, and these cos t's cancel out, So we're just left with sine squared t. And we know what we do at this point, when we've done this little working out, we'd sub in what u is, okay? And u is sine t, and we've got sine squared t. So obviously the logical explanation now is to put in u squared. And then we just simply integrate u squared, which we get u squared to be, obviously, u3 on 3, or u cubed, sorry, on 3, with limits pi in 3 and pi on 2. Okay, and then it's just a case of subbing them values in. Oh, sorry. Not right at all. I do apologise. Yeah, that's not right, and I'll explain why. These were originally x limits, and we've changed them to t limits. So if you were to do this equation, and you were to go from here, you would sub it to be sine, u to be sine t, okay? And then you could do it. So if you subbed in u to be sine t, it'd be sine cubed t, and then you'd sub in the limits of pi and 3 and pi and 2. Or you would rearrange, because these are, as we said, t limits, you would just sub in to find what the u is. So you would sub in these limits to the equation up there that we've worked out, and worked out what the limits would be if you were to use u cubed to integrate it, okay, without changing it back. It's up to you. But if you were to do that, just to clarify for you, the limits that you would use, so let me just double check, okay, the limits you would use are 1 and root 3 over 2, but as I said, it's easy just to sub sine t back in, okay, and obviously you would get sine cubed t by just putting sine t and then putting that answer cubed, okay, all over 3. And then you would times the answer by 64, and what the answer that you would get is 64 take 8 root 3, which is in the form a plus b root 3 as required, okay? And your calculator should simplify it to that form anyway. If it doesn't, and it just gave you the answer, as I said, it's been a while since I've done this question, okay? So it's 64, and then obviously it would get you whatever 8 squared is. I'm going to say it's embarrassing. It would be root 64 times root 3, which would simplify down therefore to 64 to 8 root 3. Okay, so I do apologise, my head's a bit funny. Okay, so anyway, that's your answer for question 8. It's not too bad a question, but you can see definitely the last part is horrendous, I think, because it hasn't asked you to work out, it's not told you how to work it out, so there's varying ways. Now, if there was a certain demand and you answered this in the other way, if using the substitution as cos t, then please do let me know. Or if you don't know how you would attempt it, using the substitution to be cos t, please do let me know, and I'll put up a video for you. Or if I'm speaking utter complete gibberish and you can't do that, please do let me know as well. So let me know about something, and maybe I'll respond to it if it's good. No, I'm joking. I will respond to it. Just my answers. Anyway, shut up. Okay, so that's how you would answer that. If you have any ideas of, you know, and I was saying what we do to differentiate to get that, so you could integrate to get your answer, okay, that's, if you've got a plausible explanation you want to share with everyone, please do let me know, and I'll put a video up for the benefit of everyone else using your method if it's obviously correct. But as far as I can see, that's the only logical way that I see about doing it. So I know it didn't ask for integration by substitution, so that's why I'm kind of hesitant on just saying that's the only way. Okay, but so far as I can see, that's pretty much the only way you could go about that. Alright, so that's the overview of most of parametric functions. The only thing this question didn't ask about parametric functions, if you're using this question as a bit of a recap, is the volumes of revelation of parametric functions, which is just this integration, and then you times it by pi, okay? You don't need to do any other fancy stuff with it, okay? You just times it all by pi, so you would times that answer by pi, okay? So thanks for watching, and we'll see you in the next video. Oh, sorry, I made a little mistake there. If you're going to do the volumes revelation, for parametric functions, it'd be pi times the integral of y squared dx dt or dx du with respect to either t or u. Okay, so sorry about that, I just made a bit of a hash there. Okay, so as I said, hopefully the rest of it was okay, and we'll see you in the next video.